I would invite Deepashri ma'am to start the session.
Good morning, students.
Good morning, ma'am.
Is my screen visible?
Yes, ma'am. Yes, ma'am.
Okay. So, we completed the periodic table and now we are moving to the next chapter. So, that is the chemical bonding. So, how many, so before starting the chemical bonding, so I want to say that chemical bonding is what? Actually, the bond we are learning about the bonds in between the molecules. Right, till now in the periodic table, we were dealing with metals, non-metals. Those are elements, right? We were not dealing with the molecules as a whole. We were not studying about water or carbon dioxide. But in this chapter, we will be doing that. In this chapter, we will know what is the difference between the bond present in NaCl and what is the difference NaCl and water. So what are the different kinds of bonds? So we will be learning things. So actually we see many things around us, like the number ranges in lakhs, but number with how many of them are pure? I mean to say they are not mixtures. So there will be, that will be less than a lakh, right? So we see most of the things in mixture. If even if you consider a chair, it's not made up of only wood. If like it has wood or maybe other components also. So most of the things around us are in the form of mixture. I am dealing with pure substances. So that will be less than a lakh. So interesting thing is all of them are made from 94 naturally occurring elements. So this is very important. All of them. Like if you consider wood also, it has some kind of elements in them. Elements, many elements together, many different elements together will form a mixture and ultimately form the substance. Okay, so these are the pure substances like water, common salt, carbon dioxide. Apart from this, can anyone give any more examples? Like what are pure substances? Water, common salt, carbon dioxide, ozone, that is another pure substance. Apart from this, anyone wants to add anything for examples for the pure substances? Yeah. So that can be another examples also. So those are the different list of different pure substances. So if I ask you that give me a list of chemical compounds that has one hydrogen, one lithium, one boron, one aluminum. Ca2CO3, I won't say Ca2CO3 because it is actually a mixture, calcium carbonate. Okay, it is a mixture of two substances. This is not a pure thing. Or maybe by that sense, if you say that it is just a few elements, from that sense, you can say it is a pure substance, but calcium carbonate actually has many elements together. Okay, now if I say, what is the name of a substance that has one hydrogen, one lithium, one boron, one aluminum, one carbon, one oxygen, one magnesium? One hydrogen example, one hydrogen. Anyone, just say, if you can remember anything, like one hydrogen.
HCl, ma'am.
Yeah, HCl can be a very good example. That HCl is actually a practical example where there is only one hydrogen. So, can you list all the compounds that are formed from the given elements like hydrogen, lithium, boron? But how to be sure that only those compounds exist? So let's find a technique to find all the compounds. See, hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium. So these are the different things. And if you now you have already studied the periodic table, you know helium is a noble gas. Neon is a
Yes.
this has two electrons. Yeah. Anyone was saying anything? Okay. Argon has how many? 18 electrons. That 2, 10, 18, 18, 32, that. So all elements want to have the number of the electrons that inert gases have. That is why they lose or gain electrons. So this is something we have already studied and learned in periodic table, that why all the elements want to have either 2 electrons, 10 electrons, 18 electrons, like they want to follow the nearest thing. I gave you the example for sibling, that you have a sibling and there is another student, both are toppers. Who will influence you more? Your sibling, obviously. So just consider that fluorine will try to be like neon, oxygen will try to be like neon, beryllium will try to be like helium, lithium will be trying to be like helium itself because helium is already stable. Chlorine will be trying to be like argon and so on. Okay, so these are the different things. So this serial number gives what? Gives the number of the electrons. Hydrogen has 1, helium has 2, beryllium has 3, and so on. Beryllium has 4, lithium has,
Four.
yeah, boron has 5. So these numbers we write accordingly to the number of the electrons. Or this is, I can say this is their atomic number. Okay. So see, hydrogen will gain 1 electron to become helium. Lithium will lose 1 electron to become helium. Then beryllium loses 2 electron. Boron loses 3. Fluorine will be what? Gaining 1 electron. Sodium will be losing 1 electron. So these are the different concepts that we have already dealt, where we have already dealt with the elements in the periodic table, like how to predict what are their characteristics, how will we know which gains electron, which loses electron, and so far and so on. So this is the generally carbon silicon, they don't lose. So for carbon silicon, gaining of the 4 electron is easy. So see here also, if it loses 4 electron, and here also it can gain 4 electron, but scientists have seen, that chemists have seen, for carbon silicon, which is exactly in the middle, gaining 4 electrons is easy. Okay, so this serial number gives the number of the electrons, and we actually know which gains electron, which loses electron. And for the middle elements like carbon, silicon, they can do both. If someone argues that why will be it not losing electron, why it is gaining, because there is another concept that that we will learn in thermodynamics. So for now, just real understand that carbon and silicon, for them gaining 4 electron is quite easy. Okay, so carbon and silicon, they gain 4 electron, and this is quite easy for them. Hydrogen has only 1 electron. Sometimes it will be ready to lose that electron. This is quite an exceptional case, that hydrogen can lose 1 electron. Generally it gains 1 electron and becomes H plus, but maybe it can be losing 1 electron also, and losing 1 electron will give H plus, gaining the electron will give minus. So that will be ready to lose electrons. Okay. Okay. So techniques to list the chemical compounds. Wait. So look at the table and form pairs. Choose one atom that loses an electron and one that gains the electron. So why did I tell you this? Who loses, who gains? Suppose there is one lithium and one beryllium. Do you think they will be able to form a compound? No, both are losing. So who will lose, who will gain? Okay, suppose it
Ma'am,
is ideal scenario. You have some money, you have lots of money, uncountable money, and your friend has no money. You want to give money, your friend wants to accept money. This can be a scenario. But suppose you and your friend both are poor, both are broke. So how can you guys will form a bond? Both are poor. So it is
By
too,
pairing.
yeah.
by
So
sharing, ma'am.
there you need another third party. Okay. So who will be donating electron? Okay. So in case of H2O, what happens? Oxygen has a property to gain electron and hydrogen loses electrons. Right. Hydrogen in most case will lose electron. So hydrogen has a property to lose. So one hydrogen will lose one electron, another hydrogen will lose another electron. Oxygen will gain both this electron because oxygen needs two electron and ultimately a stable compound will form. Is this part clear?
Yes, ma'am. Yes, ma'am.
Okay. So just wait. Yeah. So these are the different things like potassium, it will see in the last chart, I have told you what is potassium. So before writing a chemical formula for any kind of compound, you must have this list in your mind. Actually, I have given up to 20, but you can be writing for elements more than atomic number 20. You can write the entire chart. Okay. So I have written up to 20 because you will find most of the compounds formed up to 20. Now from this list, find potassium. So what is potassium? Potassium, can anyone tell me what is potassium and what will potassium do? Potassium will lose or potassium will gain? Potassium actually loses one electron. Chlorine actually gains one electron. See, an ideal match. KCl, HCl. Hydrogen, I told you, in most cases will lose. So that is why we write H plus, right? We very, in rare cases, we write H minus, where hydrogen has gained the electron. So hydrogen will lose one electron. Hydrogen, after losing one electron, will hydrogen can lose one electron and chlorine can gain one electron. So HCl. Okay. So this is how compounds are formed. So like KCl is formed. So these are the other examples. Just select one who loses electron, one who gains electron. KF, KH, LiCl, LiF, LiH, NaCl, NaF, NaH, HCl, HF. So we will be learning how they lose, how they gain. It's not like a bond. Like you are losing, someone is gaining, and ultimately the compound is formed. Okay, nobody asked me this question. Ma'am, that hydrogen you told me will most of the cases will lose one electron. But if it gains one electron, it will become helium. Helium is an inert gas. Why is this happening? I'm repeating the question once again. Just everyone answer this question. Hydrogen has a tendency to either gain or lose one electron. If it gains one electron, then it will be forming helium, which is a inert gas. But why most of the cases hydrogen is losing one electron? Explain, everyone. Explain, everyone.
I think it's because of its small size.
No, size has nothing to do with losing or gaining. If you are small, like your height is small, and if you are rich, so is that a bad thing? Like, is there any rule? Like, short-heighted people can't be rich. No, it is not that. Anything, think about with the periodic table.
Ma'am, it can't hold two electrons because it's small.
So, from that logic, you are saying that, please elaborate what you are saying.
Ma'am, because if it gain one electron,
It
it can't
can
hold two
also
electrons, ma'am.
If it gains one electron, it will become helium. That's what I said. Helium is an inert gas. Everyone tries to be like inert gas, but hydrogen in maximum cases, you will see it loses one electron.
because it wants to be stable, ma'am.
Wants to be still
Ma'am,
stable. Yeah, if it it is like helium, so it is stable only. Then
here helium, neon, and argon, some noble gases doesn't form any um,
yeah, so
compounds, ma'am.
actually hydrogen has maximum tendency to lose one electron because of its electronic configuration. That should be the answer. Hydrogen, one means it has only one electron in its outermost shell. Single electron is relatively far from the nucleus and they experience a weaker electrostatic force of attraction compared to the electrons in the inner shell. Okay, so it is easier for hydrogen to lose this electron and to attain a stable electronic configuration with zero electrons. Okay, so if hydrogen gains one electron, it can still achieve a stable electronic configuration with two electrons, which is similar to helium. This is quite rare because the incoming electron, that incoming electron will have to overcome the force of repulsion. Why? Because one electron is already present. Another electron is coming. So we can see that okay, and another electron is coming, so it might be good, right? But we are not considering the fact while thinking that already one electron is present. Another electron is coming. So the already present electron will pose a force of attraction, right or wrong? Okay. So just consider this fact. So is this part clear why hydrogen has a maximum tendency to lose the electron rather than gaining?
Yes,
No, ma'am,
ma'am.
I couldn't understand.
Yeah, okay, fine. Always remember this. So these are the different examples. Okay, again, potassium loses one electron, oxygen gains two electron. So two potassium atoms will give one electron each to oxygen, and K2O will be formed. Okay, so other examples like H2O. K2S, Li2O, Li2S, Na2O, Na2S, H2O, H2S. Just remember that chart. And if someone gains two electron, other one has to lose two electron, or one two times. Okay, so this is how chemical compounds are formed. Now, calcium loses two electrons, oxygen gains two electrons. So CaO. This is the practical example. And here what was happening? Two potassium were required. So two potassium, we write two potassium and oxygen is one required. So K2O1 you can write, but we don't write one. Okay. So calcium, oxygen. So CaO. Okay. So other examples are CIS, MgS, MgO, BeO, BeS. These examples you have to remember. More you remember, more it will be a benefit for you during the exams. See, calcium loses 2 electrons, chlorine gains 1 electron. So what will happen? It is a different case. So here someone is losing 2 electron, but gainer is only 1. Like it's something like someone is giving you more money, someone is giving you more food than you can eat. So there must be a friend of yours so that he can eat also, say CaCl2. Okay, so two of your friends who are hungry, that and the person who is feeding you, one person who is feeding you, two persons eating, because whatever the person who is feeding you, he is giving more than you should be having. Okay, so that is the reason CaCl2. CaF2 MgF2 BF2 BeCl2 MgCl2 CaH2 MgH2 BH2 and so on. So this is something. So now look at the table and form pairs. Same, calcium loses 2 electrons, sodium gains 1 electron. So 1 here, nitrogen, sorry, it is nitrogen gaining 1 electron, calcium loses 2 electron. Again, someone who is losing is more. So obviously 2 nitrogens will be required. So what? Ca3N2. But is this the formula like CaN2? Because you can obviously argue like, ma'am, calcium is losing 2 electrons. Nitrogen is gaining 1 electron. So 2 nitrogens will be there, N2, but calcium should be 1. Why there is 3 calcium and nitrogen is 2? We will be learning about this in the next classes, most probably. But this will be gaining 3 electrons. So if it is the formula, then Ca3N2 will be the case. Okay, so nitrogen gains 3 electrons, calcium loses 2 electrons. So Ca3N2. Okay, so apart from this, there can be, so like Ca3N2. Can you name other compounds? Anyone? Any other compound name? Write in your...
NH3, ma'am.
Yes, that can be a very good example. Okay, so Ca3N2, Mg3M2, beryllium 3N2, Ca3P2, Mg3P2, beryllium 3P2. These beryllium compounds you will be learning again in P block. Okay, so this will be 3 electrons. Okay, this will be 3. So someone loses 2 electrons, someone gains 3 electrons. So accordingly, 2 nitrogens and 3 calciums are needed and 2 nitrogens will be needed to form a stable compound. See, why I have given you all these examples? Because more the examples you need, specifically they will be asking you compounds with examples like this. Okay, so more examples you need, more you can just think that, okay, so this should be a Ca3N2 type compound. So I know what is the bond present in them. Okay, so let us find out how different types of substances are made from these 94 naturally occurring substances. Process of combination of atoms called chemical bonding involves the union of 2 or more atoms through redistribution of electrons in the outermost shell to acquire the stable electronic configuration. All atoms attract one another at small distances. Universal attractive interaction known as van der Waals force exists between all matter and plays an important role in determining the properties of liquids and solids. These attractions are extremely weak. However, and they lack specificity. They do not lead to aggregate having a special structures or composition. This is simply saying that when we are forming compounds, like when we form water, okay, so what is happening? Oxygen is gaining 2 electron, hydrogen, each hydrogen can lose 1 electron. So everyone is trying to lose or gain electrons to get their stable electronic configuration or the nearest inert gas configuration, right? So hydrogen losing one, that will give hydrogen a stable configuration. Oxygen gaining 2 electron, that will give oxygen the stable electronic configuration. Okay. Now you can tell me, ma'am, how far is hydrogen and oxygen that they can be losing electrons, gaining electrons? And it is happening so much easily. They are at very small distance. Obviously, if the distance is too long, maybe someone has lost electron, but the other one is not gaining. Okay, so you have heard of the concept that if you are buying some, suppose there is a farmer, okay, so if you are buying something from the farmer directly, cost is quite low as compared to you are buying the same thing in same quantity from your shopkeeper. Why? Because the distance has now increased. If you are buying it something from a farmer, you are directly buying it from the farmer. But if you are buying from the shopkeeper, then from the farmer, it has reached the distributor. From the distributor, it has reached the delivery guys. From the delivery guys, it has reached your shopkeeper, and then only you have got your product. So the distance is increasing, cost is also increasing. So all atoms attract one another at small distances, which is the universal attractive interactions known as the van der Waals force that exists between all matters and play important role in determining the properties of liquids and solids. These attractions are extremely weak, obviously, because it is just a distance. It is not like anyone external factors are helping them. No, it is just like someone is throwing a ball, someone is catching the ball. Okay, so this is the concept. A molecule is an aggregate of atoms that possess distinctive observable properties. Chemical bonding gives the idea of existence of aggregates, assembly of the atom that is sufficiently able to possess a characteristic structure and composition. Chemical combination takes place due to tendency of the atom to acquire the noble gas configuration and to attain a minimum energy. Yeah, that is the reason all the elements try to be like their nearest elements, right? And hydrogen try to be like helium. Beryllium try to be like helium, but fluorine try to be like neon. Fluorine can be like helium also. That is also something stable, but fluorine has to do a lot of work, losing, gaining to be like helium. So fluorine has neon in its nearest part. So fluorine tries to be like neon. So chemical combination takes place due to tendency of atoms to acquire the noble gas configuration and the minimum energy. That is the reason someone is losing electron and the other compound is saying, okay, don't waste that electron. I need the electron, because some elements have a tendency to gain electrons. Okay, is this part clear, whatever I am saying so far?
Yes, ma'am.
Okay, good. So octet rule, all atoms except hydrogen, lithium, beryllium try to achieve noble gas configuration. What is the noble gas configuration? We can say that they try to have 8 electrons in their outermost orbit. See, the KLM, K can maximum has 2 electron, then 8, then 8, then 18, 18, 32. Okay, so all these things you have read in class 10, that KL shell, L shell, M shell. So neon is 10. So 2, 8. Okay, argon is 18, 2, 8, 8. These all are inert gases. See, they have 8 electrons in their outermost shell. But hydrogen, lithium, beryllium, I have already mentioned, they don't have 8 electrons in their outermost shell. Their outermost shell is filled up. That is why they are gaining stability. Except these three, all have this electron, all try to have 8 electrons in their outermost shell. Lithium, beryllium, hydrogen achieve configuration of helium, which is 2. Anyone who tries to achieve configuration of helium will not have 8 electrons in their outermost shell, because helium is a noble gas. They don't have to travel so much. It is just like, think like that there is a village. Okay, so village has a hospital, which is very good. Okay, so now will the villagers will travel thousands of kilometers to reach the city? Government has make a house for them, has made a hospital for them, a super specialty hospital for them in the village. They can easily reach there. Hydrogen, lithium, beryllium are the villagers. They don't have to travel to neon to gain the stable electronic configuration. But hydrogen, helium, lithium, hydrogen, lithium, beryllium, they are like, okay, I have helium, I have a good hospital in my locality. So let's just be here. Okay, so that is the concept. So the tendency of atom to achieve 8 electrons in their outermost shell is the octet rule. Nothing is octet rule. So far we have learned that all the elements have tried to lose electrons or to gain electrons. Why? To become like the inert gas. Now we know that they try to have 8 electrons in their outermost shell. The same concept, they are doing all this to become like their nearest inert gas. Exception is hydrogen, lithium, beryllium, which does not have this tendency. They just like, okay, helium, I have helium, the one and only village with a good hospital, they try to be like that. Okay, so this is something, the octet rule. Chemical bonding mainly depend on the number of valence electrons, that is electrons present in the outermost shell. Valence electrons in atoms are shown in terms of Lewis symbol. Structures are written as the element symbol surrounded by dots that represents the valence electron. So what are they saying? Okay, while drawing Lewis structures, we will only consider number of electrons in the valence shell. We will not draw all the electrons. We will draw only the electrons which is present in the valence shell. Hydrogen has 1 electron in its valence shell. So hydrogen, 1 dot. Helium has 2 electron in its outermost shell. 2 dots. Now for hydrogen and helium, if you are not listening to the class and maybe painting in my PPT, so afterwards you will never understand. You will think that hydrogen has 1 electron only. So why for neon ma'am has drawn only 8 electrons? For hydrogen ma'am has drawn all the electrons. Why? Why? Because for hydrogen, total number of electrons is 1 only, and that is present in the outermost shell. So hydrogen with 1 dot means hydrogen has 1 electron. Helium, okay, whoever is doing this, if you don't feel like doing the class, get out. And helium has 2 electrons. These 2 electrons are the total number of the electrons of helium, and also they are present in the outermost shell. That is the reason I have drawn that. Lithium has total of 3 electrons, but lithium has only 1 electron in its outermost shell. So again I have drawn lithium like this. Beryllium has 4 electrons, but beryllium has only 2 electrons in its outermost shell. So I have drawn 2 electrons. So is this part clear? That why I have drawn hydrogen with 1, and always we will be writing the electrons with dots and the outermost electrons. Oxygen has 6 electrons in its outermost shell. So that is the reason oxygen we draw like this. Is this part clear?
Madam, zinc outermost electron.
Yeah, you can think for zinc, these are most common actually. You will be dealing most elements with this only. Zinc, those are transition elements. as far as I can remember. Those are different things. For now, is this part clear? You can if you want to draw the Lewis structure for a compound which has zinc, obviously you will be considering the valence shell electron for zinc. Okay, so accordingly you will draw that. I am just saying that whatever Lewis structures you are drawing, it must have only the valence electron, not you are drawing the total number of the electrons. Okay. Is this part clear? Oxygen has total of 8 electrons, but it has 6 electrons in its valence shell. So it needs 2 electron more to have 8 electrons in the outermost shell. And if it has 8 electrons in the outermost shell, then it will be having total of 10 electrons. So it will be like neon. Okay. Is this part clear? All these calculations, I hope they are going
Yes.
in your head. So there are different types of the bonding: ionic bonding, covalent bonding, and the coordinate bonding. We will be learning about these 3 bonds. What is ionic bonding? Metals, non-metals, sodium, chlorine. Whatever you are learning so far, these are the ionic bonds. Covalent bond, I have not yet given any example, but whatever examples we have seen so far, those are ionic bonds. Metals, non-metals. Main part to identify in your exam, if they want to make the exam paper tough, they can say, like, suppose A is a metal, B is a non-metal, and a bond is formed between them. Immediately, the idea should go inside your head that this is an ionic, okay, that this is an ionic bond. So bonding between metals and non-metals. So metal atoms have a low number of the valence electrons and a low electronegativity. Non-metals have atoms have numerous valence electrons. Okay, so metal atoms generally has low number of valence electron. Non-metals have high number of the valence electrons. Okay, so accordingly you will know which is losing, which is gaining, and you will form the compound. Metals, remember, metals lose valence electron to achieve a stable valence shell, usually 8 electrons. Gets a positive charge, that is a positive ion. I told you someone who loses electron will get a positive charge right from the periodic table. So metals lose electrons, so it gains a positive charge. Okay, like sodium 281. Sodium is what? Sodium is 11, right? Atomic number. Remember the atomic number. Again, I am saying that if you have not yet memorized the periodic table, please do. And please do remember what is the atomic number, what is the molecular number. Atomic number is 281. If someone says that, ma'am, why is not sodium 23? 23 is the atomic weight, not the atomic number. Okay, we all deal with atomic numbers. So now you can understand that why Mendeleev said that it should be based on atomic numbers and not atomic weights. Okay, so 281, and this is KLM shell. I hope you have not forgot what you have learned in class 10. So if sodium loses this electron, it will have 8 electrons in its outermost shell, and 10 electron is present where? Neon. So sodium will try to lose 1 electron because it accepts hydrogen, lithium, beryllium. Boron. Everyone will have 8 electrons in their outermost shell. Okay, so if it loses this 1 electron, there will be 8 electrons in their outermost shell. So that is Na plus, that is 2,8. Lithium is 2,1. So if it loses 1 electron, it will be 2. So lithium is plus 2. That is, lithium is plus. Sodium, this plus should be on head, not like beside it. So sodium is Na is plus. Lithium is plus, that is 2. Okay, so these are the different cases. See, everyone loses 1 electron, 2 electron, 2 electron. Because they will have, after losing, they will have 8 electrons in their outermost shell. Okay, so this is the case for metals. Is this part clear or not? Everyone.
Yes, ma'am.
Okay, so this is the case.
Yes.
Yeah, see, magnesium, this is an example. Magnesium will lose 2 electron. That is the reason you have seen written as Mg2 plus, means 2 electrons lost. Okay, it has given 2000 money to someone. So it has gained respect. So that is the reason plus. Sometime when I was of your age, I was always very confused that someone is losing electron. Why it is plus? Okay, so I started thinking like this. If you give someone something, respect for you increases. So increase, respect increases, so that is pass. Plus. How much you are losing, that is represented by this number. Is this part clear? Everything, why each and every notion is given here in the slide. Till now. Till now, anyone has any doubt?
No, ma'am.
Good.
Oh, ma'am.
Okay. Similarly for non-metals. If you have done the periodic table thoroughly, you know what is a metal, what is a non-metal. Then you can easily understand this. Because sometimes, see, if you are practicing a lot, fluorine, chlorine, bromine, iodine, you will know these are non-metals. Okay, so something that comes with with practice.
Most of the metals in left side periodic table.
Yeah, that is the reason. Remember, I told you that metals are here only. Remember, this part in the periodic table has only metals. That is the reason I am telling you for now, like millionth time. Remember the periodic table. Because suppose zinc, someone has told you. I can remember zinc is a metal because I have been teaching chemistry for like 3-4 years. That part has gone in my head. You are not reading this for 3-4 years, but you have to appear for exams. So if you remember the periodic table, you know where is zinc. You will know if it is a metal or non-metal. Then even if you don't remember that chart I showed you in the beginning, which atom loses how many electron, which gains how many electron, then also from seeing that thing that okay, it is a metal means it will lose electron, from that also you can solve questions. Okay, so not all your learnings will come from the books, but exactly all your questions will come from whatever I am teaching. Okay, so try to remember that whatever point I am focusing on. Non-metals. Non-metal means gains valence electron and non-metal means gaining. Okay, and achieves a stable electronic configuration. After this class, I have done up to 20, right? Up to atomic number 20, calcium, that if it is gaining or losing electron. If you are confident, then you can just do for the rest of the metals and non-metals, if it is losing electron or if it is gaining electron. Or if you are lazy, you can think non-metals. Non-metal, okay, non-metal means it will lose electron. Okay, so then write the electronic configuration. How you used to now for writing electronic configuration here, don't write 1s2 2s2, because there you will get confused. Because if you are writing electronic configuration following the rule like 1s2 2s2 2p6, sometimes you will see 4s comes before 3d. There you will get confused. What is the valence shell? Don't do that. Here, write the electronic configuration, whatever, like you used to write in class 10. K shell, L shell, M shell, okay? K shell has 2 electron maximum. Then L shell will have maximum 8 electron. N shell will have maximum 18 electrons. You used to do this in class 10, right? So write electronic configuration like that. And then you know it is a non-metal because you have learned periodic table. Then I have told you, except those three elements, all will have 8 electrons. All will try to have 8 electrons. So accordingly, start eliminating. So fluorine will gain 1 electron. Now, someone can argue, ma'am, why is not fluorine losing 7 electrons? Because it can have two. Two is helium. Is it easier for someone to lose 7 electrons or to gain 1 electron? Gain 1 electron, right or wrong? It is
Right,
easier.
ma'am.
Yeah. So now you can get confused in another concept I told you in
Yes,
class.
ma'am.
That, ma'am, you are telling, suppose consider chlorine, okay? That chlorine can lose 7 electron, it can have 8 electron in its outermost shell, it can be stable. Or chlorine can gain 1 electron, it can have 8 electrons here, it will be stable. So, ma'am, you are now telling that it is easier to gain 1 electron than losing 7 electrons. But, ma'am, the electron which is incoming, that will be that will face repulsion by these 7 electrons. Obviously, it will face, but you know what? These have been experimented by the scientists. Okay, that is it easier for chlorine to lose 7 electrons, or is it easier for chlorine to gain 1 electron? And if it is gaining 1 electron, will these 7 electrons pose any kind of repulsion? Obviously, they will pose. So, an energy is spent, but that energy spent by the incoming electron to resist that repulsion is far less than the energy which is spent by the same chlorine to lose these 7 electrons. That is what we will be doing in thermodynamics. Totally different thing. Okay, so for now, if this doubt has arisen in your mind, it is a very good and a clear doubt that, ma'am, that is the reason why hydrogen prefers to lose all electron, right? There is one more electron incoming. But for hydrogen, that energy is more. Okay, so that is the reason this concept is happening. Is this part clear what I have taught till now?
Yeah,
Yes,
ma'am.
ma'am.
Yes,
Whole
ma'am.
concept is clear. Like if I just suppose you are sleeping, I wake you up and give you an element, and I tell you that I don't even tell you it is a metal or a non-metal. Will you be able to do this if it is losing electron, gaining electrons? Okay. Yeah. So that should be the thing. This is ionic lattice. So wait.
Yes, ma'am.
Okay, very good. So what is ionic lattice? So now we know which atoms lose electron, which not atom, which element will lose electron, which element will gain electron. Okay, which is non-metal, which is metal. So that is how we are linking periodic table with this chapter. Now, ionic lattice, these are something extra that comes in your board. So positive and negative ions attract each other to form a three-dimensional continuous lattice structure. Each positive ion is surrounded by a number of negative ions because attraction. Each negative ion is surrounded by a number of positive ions. Okay, so this is how the arrangement should be. While you are writing the chemical formula, just try to follow these rules. I'm not saying if you, while drawing the structure of water or structure of NaCl, if you don't follow this, teacher will cut marks. No, but if you draw the positive ions surrounded by negative ions, beside negative ion there are positive ions, the teacher will understand that okay, this student has not marked up the formula, has not marked up the Lewis structure, rather he or she has understood, and this will just elevate your marks in your boards. Okay, so the ratio of positive and the negative ions in the lattice is determined by the charges of ions. This table shows the properties of ionic lattice. This chart is very important for your what I will say, for your Neet.
Ma'am,
Yeah, say.
ma'am, can you show
Yeah,
me the iron?
this one. Yeah, so that is what I have told. That each positive ion should be surrounded by negative ion, and beside the negative ion there should be positive ions, and ratio of positive and negative ions is determined by how many charges. Okay, like there are this many charges of the atom, there are this many charges. Just now what I have told, that oxygen will uh, gain 2 electrons, hydrogen will lose 1 electron, so 2 hydrogens are needed. Okay, so that is the thing. Whatever I have told, the same thing is written here. Now, this is very important for your NEET, and I have. Yeah, can you write in the chat box because your voice is cracking. Just write in the chat box. Okay, so now this chart is very important for your NEET. So melting point and the boiling point. So melting points and the boiling points of the ionic compounds are high because a large amount of thermal energy. For your NEET, what you need to remember, melting and boiling point of ionic compounds are high. Okay, this is for your boards. Why high? Because large amount of thermal energy is required to separate the ions which are bound by strong electrical forces. Why this is important? Because in your exam they will give you a list of compound. Okay, so after going through this chapter you will know which compounds are having ionic bonding, which compounds are having covalent bonding, which compounds are having coordinate bonding. Obviously, metals with the ionic bonding, they will have high melting and boiling point. Okay, so you can use that logic to solve the question. Electrical conductivity. Solid ionic compounds do not conduct electricity when a potential is applied. Okay, this is something you need for the need from this, because you need in your boards, because there are no mobile charge particles, no free electron causes the ions to be firmly bound and cannot carry the charges by moving. Hardness. Most ionic compounds are hard. Surface of their crystals are not easily scratches. This is again something. Hardness, electrical conductivity, brittleness, they will not give. They will maximum, they will give about melting point, boiling point. I think you have seen the questions. They give you a list of compounds and they ask you to arrange them in increasing or decreasing order of their melting point or boiling point. How do you think people know this? They just see what kind of bondings are there. If it is an ionic bonding, that compound will have the highest melting or a boiling point. Okay, so this is the basic thing. After we deal with the coordinate and other bondings, we will know about them. Method for writing formula. So what is the method? So symbol like this. Okay, so I think you have done this before class 10. Valency, you know.
Yes,
Okay,
ma'am.
always, yeah.
Yes,
So,
ma'am.
Yes.
always write the positive ion at the left hand side. Okay, it is a rule. Write the positive ion at the left hand side. Now you know which is a positive ion, which is a negative ion. Because periodic table. So now then write their valencies. Okay, this valency and this valency. So this valency will go here, this valency will go here. If these two valencies are divisible by each other, accordingly you follow. So this is the basic for writing the ionic compound. Okay, so this is how we deal. Okay. Okay, so till now, any problem, any doubts? Whole of the chapter, whole of the thing, whatever we have done in class, how to know, how to deal. Is there any doubts or any questions?
No, ma'am.
No, ma'am.
Everything is clear, right? Good. Someone has, okay. So, okay, so I am ending the class. In case you are having any doubts, like you are getting confused in any concept, tell me in the next class. Like tomorrow? Okay.
Okay, ma'am.
Okay.
Yes, ma'am. Thank you, ma'am. Yes, students. Again, we have class in the evening. That is from 6:30 to 8:30. Right? So bye everyone. Again, we will meet in the evening session.
Thank you, ma'am.